You're 60 feet below the surface of the Gulf of Mexico, miles off Alabama's coast, when suddenly towering shapes emerge from the sandy bottom. Not rocks, not coral, but massive tree trunks standing exactly where they fell 60,000 years ago. Ancient cypress trees so perfectly preserved that scientists can still see the bark texture, the growth rings, even insect burrows from an ice age when woolly mammoths roamed North America. Welcome to one of the most extraordinary discoveries in modern marine archaeology. An entire forest that's been hiding beneath the waves, waiting to tell us secrets about our planet's climate history that could change how we understand our future. This isn't just any underwater forest. Nearly 60,000 years ago, as prehistoric humans just started venturing out of Africa, a forest of cypress trees grew on the banks of a river near the Gulf of Mexico. But here's what makes this story absolutely fascinating. This forest was discovered completely by accident, and the man who found it kept its location secret for almost a decade. Why? Because he knew that once word got out, treasure hunters and souvenir collectors could destroy in months what nature had preserved for millennia. The story begins with Hurricane Ivan in 2004. Hurricane Ivan's powerful winds and waves uncovered some of the forest that had been buried under mud and sand for tens of thousands of years. Hurricane Ivan devastated the Gulf Coast back in 2004, but it also played a hand in uncovering the forest, which is about 12 miles south of the shoreline. Now, imagine you're a local fisherman, heading out to your favorite fishing spot after the storm passes. The hurricane has churned up the seafloor, changed the underwater landscape, and as you're using your fish finder, you notice something strange. Your sonar is picking up what looks like vertical structures rising from the bottom. Not the usual flat seafloor you're used to, but towering shapes that seem almost architectural. That's exactly what happened to one anonymous fisherman who walked into a local dive shop and said something that would lead to one of the most significant underwater discoveries in recent history. "I've found this spot where there are trees sticking up out of the bottom," he told the dive shop owner. Trees? 60 feet underwater in the Gulf of Mexico? The dive shop owner was skeptical, but curious enough to investigate. What he found would blow his mind and eventually attract scientists from around the world. When that dive shop owner first descended to investigate the fisherman's claim, he couldn't believe what he was seeing. 60 feet below the surface of the Gulf of Mexico, miles off the coast of Alabama, there's a window into a wild and ancient world man never knew before. Massive cypress logs, some over 3 feet in diameter, standing upright exactly where they had fallen during the last ice age. But here's the remarkable thing. These weren't petrified. They weren't turned to stone like most fossilized wood. They were still wood. Still organic. Still containing the cellular structure that scientists could study to unlock secrets about ancient climate conditions. The preservation was so perfect that mud and sand covered the forest for eons, creating an oxygen-free environment that protected the trees from the punishing environment of the ocean. Think about that for a moment. For 60,000 years, these trees were sealed in an underwater time capsule, protected from decay, erosion, and the normal processes that would have destroyed them on dry land. Now, let me ask you something that keeps marine biologists awake at night. What can trees that grew during the last ice age tell us about our climate future? Because that's exactly what scientists are trying to figure out as they study this incredible site. The cypress forest dates back to an ice age more than 60,000 years ago, when sea levels were 400 feet lower than today. 400 feet lower. That means this forest wasn't just near the coast. It was hundreds of miles inland from what we consider the coastline today. The entire geography of the Gulf Coast was completely different. The person who brought this discovery to the world's attention is environmental journalist Ben Raines. In 2012, Broughton disclosed the existence of the site to Ben Raines, an environmental journalist for a local Alabama news site AL.com, but swore him to secrecy on the tree's precise location. Raines spent years documenting this site, creating the documentary, The Underwater Forest, but he faced an incredible dilemma. How do you share one of the most significant archaeological discoveries in recent memory while protecting it from destruction? You see, its exact location remains unknown to the public for good reason. A local dive shop owner made the discovery of the forest hidden beneath the waves, and decided to keep the location to himself from fear of individuals attempting to take pieces of the ancient trees as souvenirs. And their fears were justified. Even with limited access, parts of the forest have already been damaged by visitors taking souvenirs. Imagine if the exact coordinates were published online. Within months, this irreplaceable scientific resource could be picked clean by people who don't understand that they're destroying a library of climate information that took nature 60,000 years to write. But let's talk about why this forest is so scientifically valuable. These ancient cypress trees are like natural climate recording devices. Every year they grew, they recorded information about temperature, rainfall, atmospheric conditions, even volcanic eruptions and cosmic events in their growth rings. Scientists studying core samples from these trees are discovering information about Ice Age climate conditions that we've never had access to before. They're learning about how quickly climate can change, how ecosystems respond to rising sea levels, and how forests adapt to dramatic environmental shifts. Dr. Grant Harley, a paleoclimatologist studying the site, explains that these trees are providing unprecedented insights into how North American climate systems worked during the last glacial period. The data they're extracting is helping refine climate models and understand natural climate variation in ways that were impossible before this discovery. But here's what I find most fascinating about this story. The forest isn't just telling us about the past. It's warning us about our future. The same process that submerged this forest 60,000 years ago, rising sea levels due to melting ice sheets, is happening again today, just much faster. When this forest was alive, prehistoric humans began emerging out of Africa and shared hunting places and cave residences with Neanderthal populations in what is today Europe. These trees were growing when our ancestors were just beginning to spread across the world, when the climate was dramatically different, when entire continents were covered in ice. The cypress trees that formed this forest were likely bald cypress, a species still common in southern swamps today. But 60,000 years ago, they were growing in what was essentially an inland river system, hundreds of miles from the nearest ocean. The Gulf of Mexico was much smaller, and much of what we now call the continental shelf was dry land. As the Ice Age ended and global temperatures rose, ice sheets melted and sea levels began rising. But unlike today's rapid climate change, this process took thousands of years. The forest had time to adapt, to move inland, to follow the changing coastline, until eventually, the rising water overtook even the highest ground where these ancient giants stood. What's absolutely remarkable is how the final burial happened. As the trees grew old, they fell and were buried under sediment. When the sea level rose, the remains of the forest were covered once again. It wasn't a sudden catastrophe like a tsunami or hurricane. It was a gradual process where falling trees were gently covered by river sediments, creating that oxygen-free environment that preserved them perfectly. Think about the timing of this preservation process. If the trees had been submerged while they were still standing and alive, they would have rotted underwater. If they had fallen on dry land and remained exposed, they would have decayed normally. But the timing was perfect. They fell naturally as they aged, were covered by sediment, and then sealed underwater just as oxygen levels dropped to zero. Scientists studying the site have identified multiple species in this ancient ecosystem. Not just cypress trees, but also oak, pine, and other hardwoods that formed a diverse forest community. They found evidence of ancient insects preserved in the wood, pollen samples that reveal what other plants were growing in the area, and even microscopic organisms that tell us about ancient water chemistry. Dr. Christine DeLong, a paleoclimatologist at Louisiana State University who has studied samples from the site, describes it as a treasure trove of paleoclimate information. The chemical composition of the wood reveals seasonal temperature variations, drought conditions, flood years, and even the effects of major volcanic eruptions on regional climate. But perhaps most importantly, this forest is teaching us about resilience and adaptation. These trees survived ice ages, climate shifts, changing river patterns, and ecosystem transformations that lasted thousands of years. They adapted to gradual changes that would challenge any modern forest management plan. The question researchers are asking now is, what can we learn from this ancient forest about helping modern ecosystems adapt to rapid climate change? How did these trees survive previous periods of environmental stress? What genetic adaptations allowed them to thrive in changing conditions? There's also a biotechnology angle that's fascinating. Because the wood is so well preserved, scientists are studying the ancient organic compounds for potential medical applications. Some researchers believe that trees that survived Ice Age conditions may have developed unique chemical defenses that could lead to new pharmaceuticals. The tannins, resins, and other organic compounds in 60,000-year-old wood represent chemical libraries that nature developed over millennia. Modern pharmaceutical companies are very interested in these ancient biological compounds as potential sources for new medicines. But time is running out for this research. The same forces that preserved the forest are now threatening it. Climate change is accelerating sea level rise, increasing storm intensity, and changing ocean chemistry. The forest that survived 60,000 years of gradual change is now facing rapid environmental shifts that could destroy it within decades. Rising sea levels are increasing water pressure at the site. Stronger hurricanes are stirring up more sediment, potentially burying the forest deeper or exposing it to destructive currents. Ocean acidification is changing water chemistry in ways that could accelerate wood decay. The researchers studying the site are racing against time to document and sample as much as possible before these changes make the forest inaccessible or destroy it entirely. They're using advanced underwater robotics, 3D scanning technology, and sophisticated sampling techniques to create a permanent digital record of this ancient ecosystem. Dr. Brian Helmuth from Marine Science Center explains that they're essentially creating a digital museum of the forest, using high-resolution scanning to capture every detail of bark texture, wood grain, and structural features. This digital preservation will allow future scientists to study the forest even if the physical site is eventually lost to climate change. The discovery of this underwater forest has also changed how scientists think about sea level rise and coastal geology. It's provided direct physical evidence of how dramatically coastlines can change over geological time, and how quickly major environmental shifts can happen. For coastal communities from Texas to Florida, this forest serves as a sobering reminder that today's coastline is temporary. The beaches, barrier islands, and coastal cities we consider permanent are actually just the current position of a boundary that has moved hundreds of miles over the past 60,000 years. But there's also hope in this story. The fact that this forest survived so long, adapted to so many changes, and preserved so much information for future generations shows the incredible resilience of natural systems. It reminds us that life finds ways to adapt, survive, and even thrive through dramatic environmental changes. The indigenous peoples of the Gulf Coast have oral traditions that speak of forests beneath the sea, of hunting grounds that disappeared underwater, of ancestors who lived in places that are now ocean floor. This underwater forest validates those traditional knowledge systems and reminds us that human communities have been adapting to changing coastlines for thousands of years. Today, the underwater forest continues to yield new discoveries. Recent expeditions have found preserved root systems that reveal how ancient cypress trees adapted to changing water tables. They've discovered pollen samples that are rewriting our understanding of Ice Age plant communities. They've even found evidence of ancient fires, preserved in charcoal deposits that tell us about natural fire cycles during the last glacial period. Each dive to the site reveals new details about this ancient world. Scientists have found prehistoric animal burrows preserved in fallen logs. They've discovered evidence of ancient fungal relationships that helped trees survive in challenging conditions. They've even found microscopic organisms that have been dormant in the wood for 60,000 years. The most recent research suggests that this forest may not be unique. Similar underwater forests may exist throughout the Gulf of Mexico and along other coastlines where Ice Age sea levels were dramatically lower. Advanced sonar mapping is identifying potential sites off the coasts of Texas, Louisiana, and Florida that show similar underwater topographic features. If this is true, we may be looking at an entire network of underwater forests that could revolutionize our understanding of Ice Age ecosystems and climate change. Imagine the stories these ancient trees could tell us about how life on Earth responds to major environmental shifts. So what does all this mean for us today? This 60,000-year-old forest is essentially a message from the past about our future. It's showing us that climate change is natural and continuous, but also that the current rate of change is unprecedented in recent geological history. It's teaching us that coastlines are temporary, that sea levels can change by hundreds of feet, and that major ecosystems can disappear beneath the waves. But it's also showing us that life is incredibly resilient, that natural systems can adapt to dramatic changes, and that ancient wisdom can help us navigate future challenges. The question for our generation is, what will we leave behind for scientists 60,000 years from now? Will our coastal cities become underwater archaeological sites? Will future marine biologists discover the remains of Miami or New Orleans preserved beneath future seas? And what lessons will those discoveries teach about how we responded to the climate challenges of our time? This underwater forest reminds us that we're not just experiencing climate change. We're part of an ongoing planetary story that began long before humans existed and will continue long after we're gone. Our role is to be good stewards of the information and resources we've inherited, and to make decisions that will help future generations adapt to whatever changes lie ahead. What fascinates me most about this discovery is how it connects deep time with immediate urgency. These 60,000-year-old trees are helping us understand changes happening today and tomorrow. Ancient wisdom preserved in cypress wood is informing modern climate models and adaptation strategies. The next time you walk through a forest, remember that you might be walking through a future underwater archaeological site. The trees around you are recording today's climate conditions in their growth rings, just like those ancient cypresses recorded Ice Age conditions. Future scientists may study today's trees to understand how early 21st century ecosystems responded to rapid climate change. So here's my question for you. What do you think this underwater forest teaches us about resilience and adaptation? Are there lessons from these ancient trees that could help us build more sustainable communities today? And what other secrets might be hiding beneath our world's oceans, waiting for the right storm or the right technology to reveal them? Drop your thoughts in the comments below. Have you ever encountered something in nature that completely changed your perspective on time and environmental change? And don't forget to subscribe for more tales from under the sea. Because every week we're discovering new evidence of how our planet's past can inform our future. The Gulf of Mexico still holds countless secrets, but this 60,000-year-old forest has already taught us that the most important discoveries often come from the most unexpected places, revealed by forces beyond our control, preserved by processes we're only beginning to understand.